Start today by reviewing the 11.2, whoa, that's weird, 11.3 quiz that you did over the weekend. Two questions that I think had the most, maybe the hardest of the 7 questions, and these same type will be on your test that I will send out today. Instead of sending it out Wednesday and saying you can take it this weekend, I'm going to send it out today. Thanks, Nikki. I'm going to send it out today, and you can take it after today's class anytime you want, because after today's class, we're going to start final exam review. There comes Jake. So our 11, 2, 3, 4, 11, 1, 12, all that, we'll review for that test today. So these couple of questions from the quiz are getting you ready for that. Yes, you still have one test before the final exam, and I do believe Ria had asked me last week, will these things be on the final? You could take the test immediately after this class, Annika. Yeah, the test that would normally be for this weekend, we're reviewing for it today, and we will Wednesday start final exam review. So I will email it out today. You could take it today, you could take it tomorrow, you could take it Wednesday. Not the final exam. It's not the final exam. It's this last quiz. I mean, it's this last handful. Let me try to be more clear. So 11.1, where we simplified like radicals. Like if it was square root of 18, you break it down and get the pairs out. 11.2, 11.3, which is what the quiz was, multiplying radicals together, simplifying and adding them, solving. And then your newest stuff, 5.2, 12.1, direct and inverse variation. Direct and inverse variation. That's your test for this week. But instead of saying, let's take it this Friday or this weekend, like I often say, I'm saying that you could take it after this class if you're ready, because we are reviewing for it today. Normally we would review on a Wednesday, but we're done with all the lessons. Today is reviewing for this test. I will email it out. You can take it whenever you want, and Wednesday we will start final exam review, and we will final exam review Wednesday, and we will final exam review next Monday, and we will final exam review next Wednesday, and then you can take it whenever you want. No, you don't have to, the final exam is not this weekend. It's theoretically this test this weekend, and theoretically the exam review, the final exam the next weekend, because I always just give you one paper per week. But so you don't forget, I'm telling you that today is our review for this test, and so you're welcome to just hop on it and take it ASAP after today. And then I'd say, do all those review questions that I sent, or work through as much of that as you can, or a couple of chapters of that by Wednesday, and then the next week, Monday, we'll do a few more chapters of review, and then Wednesday a few more chapters after review of review, and then by the end of next week, which is Wednesday for y'all, then you can take your final whenever you feel ready. Yep. Yeah, it's true. Rhea, are you talking about the final exam? Recordings of the final exam? Oh, since the schedule. Yeah. Let me try to say it one more time. I only give you in my schedule one paper / quiz or test per week. This week would have been this test. And then next weekend would have been the final exam. But I'm just telling you that we will be done preparing you for this test today, so you can get it off your plate as early as you want to after today, which means you will have nothing. Once you do this, you will have nothing this weekend to turn in if you get this test done like in the next day or two. But, oh, good question, Annika. I'll answer that in a second. But What you can do after you get this test off your plate is that paper of review problems that I sent out. Just start working those. After you get this test done, there's not a homework assignment today after the test. You just start working the review paper. Did everyone see that yet? Did your parents email or, print that for you? Okay, you've seen it, Tatiana. Yeah, Ria, Austin, Annika. And Annika asked, will there be a class after the final exam? No, there isn't. Next Monday, Wednesday, we will review for the final exam. You take it, you're done. No more class. Nothing. Because why would we, right? You know, all of our classes will be getting ready for the final Wednesday and then next Monday, Wednesday. So just start doing your review questions. Get this test off your plate after today's lesson sometime. Then just start doing review questions, and they're all from the back of the book. Did you notice that? It's not a worksheet of questions that I sent you to print and work off the paper. It's back of the book questions spread out through the whole year, a few here and there, all through the year. If you feel super good about the first semester, I'm not going to take them up, so this is a discussion you can have with your parents. If you feel super good about the first semester stuff, maybe your focus should be Chapter 5, Chapter 6, Chapter 7, Chapter 8, Chapter 9, that stuff. But I did want to answer Ria's question from last week. This, because I didn't remember when you asked Ria if this would be on the final, this stuff is not on final exam. So basically, I'm not giving you a test and then putting it on the final exam again. Does that make sense? There won't be radicals. Yes, less stuff, because you just would have taken a test, so that's on it. So I didn't throw it on the exam as well. So the exam is basically from, yes, Robert, to answer your question, Chapter 1 through 9 stuff. There is stuff from the first semester, mostly because, like, if you can do PEMDAS, which is what first semester was, then it kept happening. If you can graph lines from Chapter 5, then we kept graphing lines in Chapter 6, and we kept graphing lines as inequalities in Chapter 7, and stuff like that. So math builds on itself. You're right, Austin. We should call that GEMDAS, grouping symbols. Then exponents, multiply, divide, add, subtract. So see, there's, in Chapter 2, I think we did how do you add and subtract negatives and positives? How do you multiply negatives and positives? Well, obviously, you've been doing that the whole rest of the year. So I say it goes back to Chapter 1 simply because, solving equations, once we did that in Chapter 3, that kept coming up and kept coming up. So it has everything simply because math, you learn something, then you use it for the rest of the year. Does that make sense? Does everyone sort of feel like you understand what I'm saying? If you looked at your schedule, the homework schedule, it would say you don't have to take this test until this weekend. I'm just telling you, why wait? If we're reviewing for it today, get it off your plate today or tomorrow. Cool. Okay, let's flip to a new page. Let's work these couple of Chapter 11, 2, 3 quiz problems, like number 5 from the quiz. So you will have a problem very similar to this on your test. Oh, and someone asked how many questions on the test. There are 18. 18 questions. So questions 11, 12, and 13, I'll tell you this about the test. As I look at the test, number 11, 12, and 13, they're practically the same as number 3, 4, and 5 on your quiz. They're from 11, 2, 11, 3. So look at what you did on 3, 4, and 5 on your quiz. You multiplied by distributing, you multiplied conjugates, and then you multiplied with FOIL. Of course, the number 4 was conjugates, you use FOIL as well. So can you do this? square root of 8 plus the square root of 2, square root of 5 plus the square root of 3. How do you know it's FOIL? Does everyone see that it looks like a term plus a term, so a binomial, exactly, Austin, multiplied by, parentheses crammed together, looks like another binomial, right? So I'll use my color coding. First term we'll do blue, square root of 8 times 5. It's all under the radical, right? It's under the square root. The 8 and the 5 are under. Put them under, and then see if you can't get some pairs out. Break down the 8, 2, 2, 2. Break down the 5. It can't be broken down. So do you see the pairs? Grab that pair of 2s, put it out front, and I'll use black to say I'm calling this 2 square roots of 10. Okay, let's use, is that brown for O, outside, square root of 8 and square root of 3, all under the radical, so 8 times 3, 2, 2, 2, 3. Pair comes out. Positive, someone, you know who you are, who made some mistakes. Be sure to figure out what sign these all are. This was positive, this is positive. So because this was positive, this is 2 square roots of 10 plus 2 square roots of 6. In a minute, you're going to want to know whether they were positive or negative when you combine like terms. Okay, let's use purple for inside. That's a positive square root of 2 and a square root of 5. 2 and 5 don't break down any further, so there's nothing you can do to simplify that. It's just a square root of 10. And since there's nothing in front, there's just one of them. I'll use green for last of L, the L of FOIL. That was I. Square root of 2 and the square root of 3 multiplied, or just 2 and 3 underneath. Again, 2 doesn't break down anymore. 3 doesn't break down anymore. It's a positive square root of 6. Now this was the thing, right? The person who did this in error. This last step that you did get to correctly, you know who you are. This is the step where you combine like terms using Ria's favorite word, coefficients. These are square roots of 10s. They can be put together by adding the numbers out front. 3 square roots of 10, right? Because there's a 1 and a 2. There's 2 of them and 1 more of them. That's 3 square roots of 10. Now there's 2 of you that put 2 or 3 of you that put a 2 out front. I think it's because you weren't thinking of that 1 being there, and there's also a 1 there. Do you see why there is an invisible 1 there? Or shall I explain it further? You see it? You see why? Okay. One of you does. The other one, do you see that there's a 1 in front of those? And the square roots of 6 are like terms, so 2 of them plus 1 more of them is 3 of them. Yeah? Okay. Just like if you had 2x plus x, you wouldn't say that's just 2x, would you? 2x and another x is 3x. 2 square roots of 10 and another square root of 10 is 3 of them. Same exact concept. So much like combining like terms, isn't it? These might as well be x's and y's. They act the exact same way. Okay, let's look at number 7, solving equations with radicals. This, number 6 and 7, solving with radicals, or what we, same thing as square roots. The word radical and a square root symbol, it's the exact same thing. It seems like as we just get older, like into Algebra 2, we call it radicals. Okay, so what do we do when there are radicals in our equation? This is like number 6 and 7 on your quiz, and it will be similar problems to number 14, 15, 16 on your test. Test number 14, 15, 16. Okay, so what do you do? This is number 7 from your quiz. There's one of you, let me see if you're here before I say this. Okay, one of you had nothing on this answer. Do you know who you are? Who didn't put anything on number 7. And I asked you, did you just forget to write the answer from your scratch paper, or did you not know what to do? Just curious. Do you know who you are? Person who didn't write an answer in the answer blank for number 7 on the quiz. Was it because you forgot to write the answer, or because you didn't know how to attack the problem? You don't remember, or you didn't know how to attack the problem? No, it wasn't you. Person who said it wasn't me, was it? It was not you. Okay, watch me do it and maybe you'll remember. Maybe it's just been too many days since you took your quiz. You don't remember what happened? Okay, so here's the problem. We're solving, the directions say we're solving. There's an equal sign. Because there is a radical, a square root, we have to have 2 thought processes in our algebra. Used to be, back in the olden days, we would just say, let's get x alone. Now we say, if there's a radical, let's get the radical alone so we can square and get rid of it. Then we'll try to get x alone. Good, Austin. So, I'm telling you, I'm looking at number 16 of your test. They're very similar. 16 is from the test, very similar to number 7 on the quiz. Exactly, Austin. So you look at the square root and you say, is it alone on the left side of the equal sign? It isn't. See that minus 2? That needs to go over here. So you either need to say plus 2 on, just hop it across the shortcut way, or you could just think plus 2 on both sides to get rid of it. Either way, you now have the x plus 4 under the square root alone equal to 3. Does everyone see how that's what we did by adding 2 to both sides? Is that good? Okay, now that we have the square root by itself, how do we get it to disappear? What's the magic? The undoing of a square root is what? Squaring. Good. Austin, I assume that's what you mean, right? Square it. Square root, square. Undo. They undo each other. It's like magic. And of course, we always, to be fair, so that our equal sign stays equal, we square the other side. Now the left is beautiful because the square root of 2 and the square root and the square undo each other, leaving just the stuff that was under the square root. Okay, other person who made some mistakes on this quiz, I think you put 16. Yeah, you see it? Do you see why it's not 4 squared? Because the square root being over the 4 as well, all the squaring does is kills the square root. Oh, I like your wording. Yeah, leaving the x plus 4 as is. Squaring kills square root and that's it. It can't work its way down and also square the 4 because it would be like double powerful, but it isn't, if that helps. Okay, so we're left with right-hand side 9, 3 squared, left-hand side just what was under the square root. Now this is like super easy algebra, right? We don't have to do the factor times factor because look, just x to the first, and that's the only x in the whole thing. No squared x's mixed with x to the first. We just need this x alone, so it's a quick minus 4 on both sides. X equals 5. Does that make sense? Especially to those of you who missed it. Yes, you can check it. I love it, Nikki. Let's always check. On 14, 15, and 16 of your test, you're solving, so they should check. Your answers should check. If they don't check, so people who missed number 7, whatever you got didn't check. And here's what checking looks like. I'll use green. Write the original problem, But now put a 5 where this x was. Square root of 5 plus 4 minus 2 equals 1. Now work that out. It's square root of 9, which is a 3. Remember, we're only using, and they put nothing in front of these square roots on these problems, which means only the positive square root. 3 minus 2, does it equal 1? Why, yes, it does. So your 5 is good. Good, Nikki and Austin, for telling me to check. Let's quickly review what you are doing when you're solving on your test 14, 15, and 16. You will have radicals, square roots, in the equation. You will get it alone first. Maybe you'll have to do something like we did, plus 2. Maybe it'll already be alone. Some of them are easier and it's already alone. Some of them aren't, and you'll have to do something, get rid of something, like we did with the minus 2 to plus 2. Get rid of the thing, whatever it is, if it's not alone. Then, step 2, you can undo the square root by squaring. Square both sides to make the square root go away. Then it's just solving. Whatever it takes, solve for variable. We can pick up another one of those in a minute. But do you see? You see what we got to do there? Does that make sense? If you see a radical, you're going to do your algebra, get the thing alone twice, 2 different times. First, get the radical alone to square it away, then solve for the variable, so get it alone. Okay, now, what I want to talk about next is that new lesson that you did on direct and inverse variation. Okay, so you will have on the reason this test has a weird extra, well, it's not the reason, but number 17 and 18 on the test, the last 2 problems, one is a direct variation and one is an inverse variation. Question. Now here's what you're going, this is how you know which is which. You see these words, direct. Assume y varies directly as, or I like to say with, x. See that word direct? That means you are looking for a y equals, we say k, x, something times x. Now how do you find the something? I have to give you an xy pair. Right? Okay, so what from your, and this was 5-2 lesson, what can I work from your 5-2 homework assignment? Any particular? Or you want me to just grab one? There will only be one on your test. One of each. So watch for direct, watch for the word inverse. First direct. Quiz, a homework question. Anyone have a specific one from your homework? Okay, I'm just looking back and I'm going to look for one. Okay, so here's number, I don't think you did it. Here's number 36 from your homework. You probably just did odds. So here's what the directions say. It's direct variation. The directions of the homework said it's direct variation. You look for the word direct. You think, because this is not given, you must know that if it's direct variation, it's y equals something times k. Remember, the inverse is y equals something divided by x. I'm sorry, y equals something times x. Direct is times, number times x. Inverse is number divided by x. Then they have to tell you a y and an x pair that works. In number 36 from that homework, it says y equals negative 18 when x equals 6. So now we know these go together. So we use them as y and x. Now, did you catch that the math is always the y number divided by the x number? Do you remember that? That always is how you find the k, the unknown front number. It's just the y number divided by the x number. Why? Because since it's set up like this, you always have to divide by the x to find the k. What's negative 18 over 6? Exactly, Annika. Negative 3 is k. Now the next thing I'm going to say, I've got 2 blanks by number 17 on the test, and it will say, and number 18, it will say, write the equation. I'm having you do this to help you. It's a step-by-step process because there's another question coming. So write the equation. What's the equation now that we know what k is? Stick the k right there, right? So write the equation, y equals negative 3x, not k. Negative 3 is k. That's blank number 1. Write the direct variation equation. You see why I did that? I know it's an equation, y equals something times x, if they say direct. I use the pair they give me to find the k, the something in front of x, then I fill it in. Now, second part of question is, on number 36, find x when y equals 6. What do we do now? We use that as that 6 as y. We use the negative 3 that we found, and all we don't know is this, the x. So solve. What must x be? Divide both sides by negative 3. Divide by negative 3. Do you say negative 2? Yep. Good, Austin. Right? Negative 2. Divide both sides by negative 3. The left is negative 2 equals x. So that's blank number 2. Blank number 1 for these problems would be to write the equation. I'm asking you to find k first and put it into the equation. That's the first step you have to do anyway. Then they give you another scenario using that y equals negative 3x, but they only have to give you y or x, and you can find the other. You need to see that again? So the words you're watching for, direct variation. Y varies directly with x. This is a direct variation problem. Something like that. When you see direct varies, variation, you need to think, I'm trying to find the number that's multiplied by x. You need to think, direct variation equation is the very basic y equals something times x. Then you need to look and say, she has to give me an xy pair. There's no other way to find it. So here's number 34 from that same homework. The next thing you've got to be told is that y equals 36 when x equals 6. So what do? You take that information, that y, that x, you use that to find k. 36 equals what times 6? What's k? It always ends up being the y number divided by the x number. Exactly, Tatiana. Exactly, Annika. Do you see it? Y'all have been a little silent. Good, Austin. Anybody else see what must k be? There's only one thing that makes sense. 6 times what is 36? Good, Colette. Good, Robert. Good, Rhea. Just divide by 6. If 6 is k, then good, Annika, that's my first. So the first blank will say, please write the equation here. What's the equation? Y equals, and now we know that k is 6. So it's a line. It's a line equation. Y equals mx plus b. but there is no B because these all go through the origin. Exactly, Austin, good point. Why all your y's are 6 times larger than your x's, so that's a good thing to keep in mind when the second part of the question happens, which is this. Part 2 says on number, what do we do, number 34, find x when y equals 42. Basically, they're asking for another ordered pair on this line. Well, if that's 42, exactly, Brock, exactly, Annika, 42 equals 6 times x. What's x? Divide by 6. Good, Tatiana. Good, Austin. Must be 7, right? 42 divided by 6, 7. So that's the second blank. 2 blanks on number 17 and 18. First blank will be write the equation. How do you find it, or how do you write it? Figure out what k is. If it's direct variation, folks, this algebra always ends up just being the y divided by the x, and boom, you got k. Once you've got that, the second question they ask, you use that. Plug in the one they give you, 42 for y, solve for the one they didn't give you, x, by dividing both sides by, ends up being k, whatever k was. Okay, what's everyone's feeling on direct variation equations? Good. I got a good. It's not, I appreciate that you said that. Someone said it's not hard at all. It's really not. It's really simple algebra. It's just that you need to recognize direct variation, direct vary, x varies directly or y varies directly with x or as x, that if they say direct variation in some words, this is the equation. They always give you enough to find k, and then when they ask the second question, you've got enough to find the other thing they ask you to find once you find k. Okay, so the other question from 17 and 18 must then be an inverse variation equation. All the steps are the same. You just have to think not y equals k times x, y equals k divided by x. If you see the word inverse, not the word direct, this is the equation that you need to think of. You need to know it's the divided by x. The x is the number, the unknown number, divided by x. So this is the 12-1 homework assignment. Any questions from you from the 12-1 homework assignment? You see why I taught them together? They're so parallel. So what do you have to have? They've got the problem or the test or whatever, I will give you an XY pair so that you can find K. Do you have a homework question or do you want me to pick one? On this homework, they did a bunch of decimals. I'm not going to do that to you. So let's do number 18 from this homework assignment because that's more my speed for your test. I'm not going to give you decimals. I'm just going to give you more straightforward stuff. So I'm going to give you the word inverse variation. I will not tell you it's this equation. You're supposed to know inverse means k divided by x. But I will have to tell you that y equals 7 when x equals -2. So just as the other direct variation, you take the pair I give you, plug it in, and solve for the k. What is it? Okay, so 7 equals what over -2? Right? Good, Annika. So either you see that that's a -14 because you think what divided by -2 is a +7, or if you don't, if it's not that straightforward, you think, okay, how do I solve for something divided by -2? I undo it by multiplying by -2 on both sides. Now do you see why -14 is k? So blank number 1 for that problem on the test, there's 2 blanks. First one will be write the equation. I ask you to do this because you need to do it to do the second part of the question. So I just decided, let's make it part of what you have to do, almost like I'm helping you know the steps to take. First, write the equation. This equation would be y equals negative 14 divided by the x, right? Once you find the k, you rewrite this equation, plugging in the k right there, leaving y and x. Just like y equals mx plus b line equations, you always left the y and x as variables. Same thing on these. Then the next thing we will ask, or the test will ask, is new scenario. Find y when x equals 7. Okay, so what must it be? You already, wait, how did they ask that? Oh, I'm sorry, I just realized they asked it back. I was like, did they just tell you the same stuff twice? No, it's a different pair, right? Different pair. Okay, so let's plug in using this equation. We don't know why. Negative 14 divided by, they said use 7 for x. What does that equal? Bunches of you said negative 2. You see that? That's why. So that's our second blank. Use what they give you and find the one they're asking for. So I ask you to do 2 blanks on number 17 and 18 on the inverse and direct variation because you have to find this equation first, then use that information to answer the second part of the problem. So I'm just making it 2 parts of the question because it will help you, like hint, hint. Don't forget to find k, make the equation, then use it to find the second, relationship, XY relationship pair. How do you feel about the inverse variation? Shall we do another inverse variation? Okay, let's do another inverse. So you see these it's either 17 or 18 of your test. You're going to see words with this, I don't care what else is around it, that is in it. That's in the directions. You need to think, okay, that's the one where it's y equals a number divided by the x. Be careful. My fear would be that you would flip those over, like y equals x divided by the k. That's not right. Don't put the k on bottom. It's the x that moves. Either the x is multiplied by the k, indirect, not indirect, but in the direct variation, or x is divided in the inverse. So x on bottom, careful, don't mess that up. Now you just have to be told something. When y equals 10, x equals, oh no, negative 5. Oh, k's on a table. It does with the little cross-legged, it's like a TV tray. Okay, so anybody know what k is right now? Exactly, Austin. So Austin, have you figured out what always happens in the inverse? Okay, if you said negative 2, you did the steps for direct. The steps that seem to always have, good Robert, good Annika, the steps that always seem to happen with inverse is that you multiply these two. Did you notice that? Whereas in direct, you have to divide y divided by x and you always get k. With these, you end up doing x times y. Why? Why? Because try plugging it in and you'll see the map always occurs this way. The 10's over here equals the k divided by the thing they gave you for x. To get k alone, you always end up having to multiply by the divided x, which means y gets multiplied by the x. That times that always gives you k. Negative 50 equals k. Perfect. Good, Tatiana. Did I say that earlier? Okay. And now, blank 1 was write the equation. So remember, you're putting the k in the top. y, and leaving the x and y equals a negative 50 over x. Step one, you got to write that equation. Then they're going to say, second part of the question will be, find y when, wait, I'm actually going to double check. Yes, find y when x equals 25. Making sure I don't give you a decimal. Good, Austin. Okay, so what do? You take that information. Ooh, very close. Check your sign, Robert. Annika, that's right. Oop, check your sign. Yep. Yeah, I think, yes, Tatiana, yes, Robert, yes, Austin, yes, I think it's -2. I made this up, but we're trying to find y, so we don't plug in y. Y equals, we know the top is a -50, we know the bottom is 25, that's where x is. What's -50 over 25? -2. Exactly, Robert. Yeah, since only one of them is negative, you end up with the opposite signs divided. Rule is negative answer. So that would be blank number 2. Okay, how are you feeling about inverse variation? Was it our last answer? It's probably because I'm making up 2 basic ones. But honestly, I didn't, 17 and 18, I made sure they're not bad answers. There's no decimally answers on 17 and 18. Like your K's are whole numbers, and then when you have to solve for the missing thing, the second part, those are whole numbers. So if you get a funky decimal, you probably backwardsed it. And what I mean by that is you probably treated an inverse like a direct, or you treated a direct like an inverse. So what are you going to think on 17 and 18? Maybe this is the first thing you need to do when you take your test, because some of you are going to take it today. So you're going to go to 17 and 18, back of your second page of your test, and you will have just reviewed that the direct variation equation is this, and the inverse variation equation is this. And you'll make sure you jot down, if this is the one that has the word direct, you're going to jot that onto your paper. And if it's 18 that has the words inverse, you're going to jot that. And you're going to be super careful to make sure your x is in the denominator on that inverse. Don't stick it up top. K and x are so similar looking letters. Just want to make sure you're thinking x in the denominator. Okay, shall we go back to the radical stuff? This is only 2 questions, which means 1 through 16 is all radical-y stuff. Simplifying them, multiplying them, solving with them. That was 11, 1, 2, 3. And that's the rest of your test. Just for fun, let's go back to easy peasy. Let's do 11, 1, simplify. See if you remember how to simplify. How are we going to simplify? I'm going to get your test, actually. We don't have to. It's only test review. Yes, Tatiana, all we're doing is getting you ready for this test. That's why I say I feel like you ladies and gents will be ready to take this test after today's lesson. I mean, we've got, what, 35 more minutes of class? So 11.1. It was simplifying radicals. Now I think it was easy except for the rationalizing the denominator. So let's do a few basic simplifying, and then we'll review how to rationalize the denominator. There's only one of them, number 6. But 1 through 5 is just simplify them, and there's 2 where you multiply them. So what are you going to do about this? Let's do this, 60. X to the 4th. What are you going to do? All it says is simplify. What do we need to do that 60? Break that puppy down. Good. Exactly, Tatiana. Let's break 60 down into all of its prime factors. It's x to the 4th. Robert, sorry, it's not clear. Exactly, Austin. That's what's going to come out front. Let's break the 60 down. 60, either use a factor tree, 6, 10, which is 2, 3, 2, 5, or maybe you can figure that out in your head, but since it's a test, take the time to make sure you don't mess up breaking down 60. So you get 2, 3, 2, 5, and then what's the x to the fourth? X, 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 right? 4 x's. Now pairs get to come out, right? There's a pair. So a 2 goes out front. There's a pair. There's another pair of x's. What stays under? Everything with no twin. So out front, so underneath we still have a 3 and the 5. Out front stuff, multiply it together. 2 times x more simply would be 2x squared. Underneath stuff, multiply it back together, 15. That is the answer. Anybody lost on this? How do you feel about that? Goes to that. Not bad? Good? Good, Robert. Good. Austin says easy, easier, and easy peasy. Got a good, got a I got it. Good. Derek, Jake, thank you. Okay. What about if you're asked to multiply them together? Okay, maybe I should just do this. What if it's something like that easy? Not even any variables. Surely you're not going to get thrown off by that, right? Just break that puppy down. 120 is 12 times 10. What's 12? 2, 2, 3. What's 10? 2, 5. Pair. Goes out. I see no more pairs. Meaning 6 times 5, 30 underneath. Would you like it if I told you there's a couple that are just that straightforward? Isn't that good? Yeah, early on in the test. It's just, so don't, sometimes I think things are so simple that we overcomplicate them. If the directions say simplify, whether it's got just numbers or numbers and variable, just break it all down, look for pairs, pull pair, any pairs come out as 1 up front, otherwise it stays under. There are only 18 questions on the test. The first ones are simplifying like this, or something more, like what's 15, square root of 15 times the square root of 20. Now, do you think I want you to write the square root of 300 and leave it? No, I surely do not. I want you to break down 15 and 20, so don't even waste your time calling it 300. Just break down, because then you have a bigger number to break down. Just break down 15 as you write it under. And remember, since they're under the square roots, they all can go under, multiplied. 15 is 3 times 5. 20 is 2 times 2 times 5. Look for pairs. There's 1. 2 gets to come out. There's another pair. 5 gets to come out. What stays under? Mr. 3. Is it 7 square roots of 3? No. Good, Austin. Good, Annika. No, these get multiplied back together. Don't call it 7 square roots of 3, please. 2 times 5, 10 square roots of 3. Do you know why? You know why? Think about what I said it was, the square root of 300. What's 300? 100 times 3. You see that perfect square right there? 10, and the 3 had to stay under. See? So that's what this was. This 5 pair and this 2 pair is really a 25 and a 4, which is 100. Square root is 10. Just pulling pairs out. Now what if some of your numbers, what if you have like 5 square roots of 5 times 3 square roots of 20? Did these go under the square root now? No, you don't force things under the square root if they weren't there. So they just multiply, right? 5 and 3 is 15. What goes under the square root is the stuff that was under the square root, and then we break it down. So under the square root, we've got 5, which does not break down. We've got 20, which is 2 times 2 times 5, and oh my goodness. As Austin said the other day, what did you say about them? They're free. It's all free. They're free from the chains of the radical. These both come out as a 2. Pair of 5s come out as a 5. How do they relate to the 15? They all multiply. 15 times 2 is 30, times 5 is what? 60? No, 150. What is it? 15 times, did I do that? 30 times 5. Hello, yes. 150. Why did I? Yeah. Look at that. You were right, Robert. Yes, my brain got lost. See that? Don't question your existence. Your math teacher messes up. We all mess up. Okay, so you're going to have one like that where there are numbers or coefficients in front of your radical. So just multiply those together and then still break down the stuff under your radical, under your square root, pull out pairs that you can and multiply them by that number out front. Don't ever add, once you pull stuff out, pairs out as a single one, don't add them together, always multiply them together. Okay, rationalize the denominator. Here we go. So remember that funny little rule we learned where you're not allowed to have an irrational number in the denominator? An irrational number is like the square root of 5 or the square root of 3 or the square root of 10 or the square root of 30 or pi. Yes, but we won't have pi's, Nikki. You will have the square root of something that wasn't a perfect square. Therefore, if you put it into your calculator, you'd get a crazy decimal. Well, those aren't allowed to be in the denominator, someone decided. Someone in math land. So, if you have, let's say you have something like this, 5x square roots of 3. Where is the problem? The problem is that when you, remember the square root on the whole fraction can be separated out? Here's the problem. That isn't a square root of a perfect square. It can't be turned into a nice pretty number, so we have to use our little manipulation of math. We need to multiply it by the thing that will make it turn into a pretty 3. What will make a square root of 3 turn into just a pretty 3? Multiplying it by itself, right? Because a square root of 3 being squared they undo each other, leaving a 3. Isn't that what multiplying something by itself is? Squaring? Okay, so we're going to manipulate the denominator to make it turn into a pretty 3 by multiplying it by itself. And then you have to be fair. You can't change the value. You can't change the value of this, so we have to multiply the top by square root of 3 as well, because in essence what that means is this blue thing is just multiplying by a 1. Therefore, the value of the thing I get over here will be the same like number value as the first thing. It just will have fixed this problem, rationalizing the denominator. Not an irrational in the denominator, but a nice, pretty rational number, 3. So what happens up top? Okay, is there a square? Yes, this and this being multiplied all get to go under the square root. 5x3. Any pairs? No. So they all just stay under the radical, and I would just put the x second. So 15 times, or 5 times 3 is a 15. The x stays there. And now is our denominator not irrational? Yes, so we've done that. So if you've got stuff in the numerator that you have to multiply together, just follow the same rules we were doing in the last couple slides. If things are under the radical, they all stay under. If there are pairs, great, pull them out front. There weren't in this one. Yeah, I can make up another one. You know, what you could do kind of to check this, you could take your calculator and you can't do anything with the x, but you can say the square root of 5 divided by the square root of 3 and get the crazy decimal, and then see if the square root of 15 divided by the number 3 gives you the same crazy decimal. Does that make sense? They should. You can't do any, the x is a mysterious number, but you could at least see if the square root of 5 divided by the square root of 3 gives you, I don't know, like 2.8753 ... Then the square root of 15 divided by just the number 3, not square root of 3, but the number 3, should give you that same crazy decimal. Because you weren't supposed to change the value. So that would help you know if you messed up on your math and you did something wrong up here. They wouldn't be equal decimals. Let me make up another one of those. So the square root of, I don't know, let's say 9x divided by the square root of 2. I learned my lesson about letting things be cancelable. Remember that, Annika, on the quiz? I made an easy one. No more easy ones. Okay, not that it's that hard, but think the square root spreads out. Oh, now look, I did make an easy one. Yeah, that one was super nice. This is actually easy because of the numerator, but the denominator I still have to rationalize, so that's the most important thing I want us to practice. Rationalize the denominator. Okay, so the problem is that this square root of 2 cannot stay the square root of 2 in the denominator. So our trick is to multiply it by itself so it cleans up to a plain 2, plain old 2. And then up top, you have to multiply by the same thing so that you are in essence multiplying by 1, something over itself. Now, look at this. Square root of 9 and x, square root of 2, those can all go under, but 9 is 3 times 3 times x times 2. So my 9, exactly, Austin, and that's what I realized when I wrote that. I was like, oh, I wrote a perfect square. That could have come out up front. So that 3 gets to come out in front, but the 2 and the x have to stay under, and then that's divided by a 2. Now, do you remember if these were cancelable, you could have canceled those, but they're not. 3 and 2 don't both divide by 2 or something. If we had had 6 over 2, you could have reduced it to 3 over 1. But this is more like the test question. These last two I made up are more like the test question, if that means something to you. Exactly, then you wouldn't have a denominator. Let's pretend like it had, the final answer was something like 6 and square root of 2x over 2. Then you could cancel these, 3 and 1, and then the simplest way to write this would actually have been just this. You don't need to write the denominator 1. That's nice. But as I said, the top problem is more like the quiz problem. I mean the test problem. How are we at simplifying when the whole combining like terms type simplifying? Let's grab some of those from, it was the 11.2 stuff, which was on your quiz, but let's pull some from this study guide and review. Here's number 15 from the study guide and review. 2 square roots of 3 plus 8 square roots of 5 minus 3 square roots of 5 plus 3 square roots of 3. And the directions will say simplify. So what do? It's practically the same as combining like terms. So look for what has the exact same stuff under the radical. Those are like terms. do the math with the upfront numbers, which are called the coefficients. 2 of them, 3 of them, all positive, 5 of them, right? Now the other like terms are the square roots of 5s. Do the math with the coefficient. Positive 8, negative 3. So we've got positive 5 square roots of 5, and you're done. Now what if they don't appear to be like terms? Is there a chance they still could be? Here's study guide and review, question number 19 from 11-2. Exactly, Austin. When you see these numbers, you'll say, ooh, those are big. I bet there's some pairs in there. We know there's a pair in 18, right? Because 2 times 9, 9's a perfect square. So you take a couple lines to break each one down, just like we did earlier when the question was just simplify. Take the simplifying route for each of these, then see if we've got some perfect squares. Cool, Austin. So Austin says this, let's do it in blue, is 5 outside, but break down the 18. 3, 3, 2, right? 9 times 2, which means we've got a pair that comes out front. 5 times 3, not 5 plus 3. 5 times 3, 15 square roots of 2 is what that is. Okay, now this is a negative 3 out front. Break down the 112. 112, help me out there. Austin says it's 5262. We got to break down the 6, right? 112. My best bet is just dividing in half. So 2 goes into that 556. Divide in half again. 2 goes into that 2, 8. Did I do that right? Help me if my brain's not working. Is that right? Am I doing it right? Was 2 times 28, 56. That's 25, 50. Yeah, 8. Okay, that seems right. Okay, 2 times 14. 2 times 7. So I need to put 2, 2, 2, 2, 7. 112 is 2, 2, 2, 2, 7. Remember the end of each branch when it stops at a prime. You want every branch to end in a prime, and all those ends of branches are these numbers. Now, what do we have here? A pair comes out front. Another pair of 2s comes out front. 3 times 2 times 2. So a negative 6, 12 square roots of 7. Thank you, Tatiana, for helping me not mess up. Good. Austin, are you giving me 98 already? Okay, so this would have been your scratch paper. I'm going to clean it up. Okay, Austin's already breaking down 98. Again, I'm not going to know 98 off the top of my head. You don't have to either. It must be 2 times 49, because 2 times 50 would be 100. 49, 7 times 7. Oh, cool. Got it. Oh, good, Brock. Thanks, Austin. Yeah, exactly. So 2, 7, 7. That's 98. So minus 3 times under the square root 2, 7, 7. The double 7s get to come out front and multiply by that 3. The 2 has to stay under. So we end up with a negative 3 times 7, 21 square roots of 2. Oh, yes, look at that. Exactly, Austin. Look, a square root of 2 and a different square root of 2. So those are like terms. So we do the math with a 15 minus 21. Exactly, they're 6 apart, and the negative team wins. So negative 6 square roots of 2, and then this doesn't get to combine. That's as good as it gets. How do you feel about that? That's about as hard a simplifying as we've ever done. And not that it's difficult, it's just that 98 and 112, I had to use the factor tree, which I often don't have to do because some numbers are small and you can do it in your head. Cool. Okay, well the next thing that is going to happen is that you're going to be asked not just to combine like terms, like simplify and combine, but you're going to be asked to multiply them together like you were asked to do on 11.3. No, that's still 11.2, sorry. So something like, from the study guide and review, we have, I'm going to pick number 22 from 11 to the study guide and review. Number 22 looks like this: the square root of 5 parentheses 2 square roots of 5 minus the square root of 7. Do you see that that's just a single square root or single radical multiplied through the parentheses, so it's basically distributing? You just have to be careful as you do it. The stuff out front, like this 2, doesn't get put under the radical. It would get multiplied by something in front of that if there was something in front of that. Numbers out front stay out front and multiply together. There's just a 1, so it's 1 times 2 is 2. But what's under the radical? 5 times 5, which pairs up and comes out. So it's really just good. Yes, Austin, it's just 2 times 5. A 10 is what that one gave me, with no more radical. Everything's free. Everything's out from under the square root. Let's do the second one. The square root of 5, which is positive, times a negative, so that's a negative. The 5 is under, the 7 is under. They don't have any pairs. So it's just minus the square root of 5 times 7, 35. And that is as good as that can get. You're going to have one problem, I believe, like that. And then you'll have some that are foilies, like number, here's 23 from that 11-2 study guide and review. Can you foily these? Okay, so I like to use my colors. F, I'm going to do in blue. So nothing in front of 3, a 2 in front of that. So 2 out front, square root of a 3 under and a 2 under, and exactly, Austin, they don't pair. There are no pairs. So more simply, that F answer is just 2 square roots of 6. Okay, I'll use green for O outside. Positive times a positive is a positive. The square root of 3 times the square root of 3, ooh. Square root of 3 times the square root of 3 makes the square root of 9, which is a positive 3. I love that. Isn't that great? Okay, let's use purple for the I, the inside. Negative times positive is a negative. The 2 out front stays out front. And then see those 2's underneath? Look what they do. They pair up and come out, meaning we've got a negative 2 times another 2, a negative 4. Oh, yes, Austin, that's last. Okay, I'll use red for last. Last times last, a negative times a positive is a negative. The square root of 2 and the square root of 3 all under the radical, no pairs. So we have a negative square root of 6. You see like terms? Those are a negative 1, right? You could write them first if you want. Order doesn't matter on this. And then these are like terms. What do we do? 2 minus 1. 2 square roots of 6 take away a square root of 6 is just a positive square root of 6. You don't have to put a 1 in front of it, but I wouldn't count off if you said there's 1 square root of 6. Good, Annika? Good. Yes. Okay, Austin and Brock, yeah. Does this make sense? How are we feeling about foiling? Andrew, thank you. Good. Good, Jake, so glad. Austin, yes, you've been right with me. Very well, Austin. Brock, Annika, thank you, thank you. Okay, anybody, so you've seen it all. You've seen all the parts that could happen on your your test. I just think we should maybe do a couple more solving equations ones. Or what do you think? Would you rather FOIL some binomial ones, or would you rather solve with the square root in the problem? FOIL or solve? I feel solve. You're saying solve, so let's do solve. Or we could be done, but I don't want to let you go early when your test grade depends upon the best review possible. Okay, let's go to the problems from the Study Guide and Review 11.3. And I'm going to keep your quiz in hand as I do this. Okay, I'm just going to make some up. I keep saying quiz, I mean test. Okay, so here we go. Making some up, looking at your test. If that doesn't tell you something, well, it should. Okay. That's real close, Austin. Real close. Okay, what should we do when the directions say solve? Get the radical or the square root thing alone first. How do you do that? Pop that 7 across. It's a plus 7 on both sides. We've got the radical alone. What's that? 20. I made this up. 22. Now what do you do? Square both sides, right? Got to get this to go bye-bye. To make it go bye-bye, you square both sides. X equals, I don't know what 22 times itself is, but here I go. 4, 5, 0, 4, 5. Did I do that wrong? 594? Do I remember how to do this? That's the question. I know, someone got 4. Okay, so, 2 times 2 is 4. 2 times 2, oh, I shouldn't have, look at me just putting a 1 up there for 0, no reason. Okay, you're right. Good, Annika, thank you. 4, 84. Some of us can't do our early math anymore, can we? 4, that's me, I mean. You're welcome to use a calculator also. There's really no, I mean, the calculator can't help you simplify radicals. Or if you know how to use your calculator to simplify radicals, do not use it. That would be cheating. Graphing calculators can be put on a mode to not give you decimals, but instead give you simplified radical answers. Don't do that. Do you see what we did here? Square root in the problem, get it alone. What do you do to get rid of it once it's alone? Square both sides. And we were done. Usually right here you'd start solving for x, except we're done here on this particular problem. What if there's a little more to it? Like, you know what I'm going to do for you? You're welcome. I'm going to do a harder one. It won't be this hard on the test. The main test. It won't be this hard on the main test. Okay. And this is the part that's going to make it. We're going to end up having to square the x, and I think we're going to have to factor equals 0. But, of course, using the basic steps, exactly, Austin, we just need that radical to be alone, meaning this has got to go, which means minus x on both sides. And exactly then, once that radical is alone, 3x minus 14, all under the radical, equals 6 minus x. We've got to square both sides. And this is the part I'm saying will not happen on your main test. Remember, this is a binomial squared, but you can take it. You could do it if you needed to. You could FOIL it. Good, Austin. 36, negative 6x, another negative 6x, and a positive x squared. That makes a negative 12x. So you end up with, on the left, a pretty 3x minus 14. On the right, this third. And remember what I want to do when I rewrite these? Descending power on the x's. And now, how do you know you have to do the FOIL, the factor times factor equals 0 because you got a square to the first to the first. You got mixed powers on your x's. You know I want to put everything on the side where the x to the second has just a positive sign in front. So I'm going to do minus 3x plus 14 on both sides. 0 equals, exactly, Austin. Once I put this all together, I will ask the question that Austin just answered. Is it easy unfoiling or the harder unfoiling? Is that 50? It's the easy kind, exactly, Austin, Tatiana, and Annika, because look, nothing in front of the x squared except a positive 1, which means easy unfoiling, you can just go straight to figuring out the binomials, knowing that the x's made the x squared. You just have to ask what multiplies to 50 but combines to negative 15. Good, Austin. Anyone else see it? What multiplies to a positive must be two same sign numbers. The same signs must have both been negatives. And they had to add to 15 because same signs in a tug of war add together. So it must be 5 and 10, and they must have both been the negatives. So what are your answers? Gotcha, Colette. No problem. Go ahead. You've seen it all. Do you think your answers are 5 and 10? It could be, but you need to always check these. Because guess what? One of those is no bueno. What do you think's not going to work? Hard to tell, right? Let's just check them. Hard to guess. Oh man, I'm going to use this space right here. Just for fun. Which one's a dud? Oh, Andrew says 5 works. Okay, so let's check 10 first. I'm rewriting this 3 times 10 where the x was, minus 14 plus 10 equals 6. Annika says 10 doesn't work. Austin says 10 is a dud. Okay, let's see why. 30 minus 14 is, what is that? 16? Square root of 16 is positive 4. 4 plus 10 does not equal 6. Yeah, that's a big no. So 10 is no good. Let me show you. Let's look at 5 and see how it works. Let's see a working one. Square root of 3 times 5 minus 14 plus the 5 equals, or does it equal 6 is the question. 15 minus 14 is 1. The square root of 1 is 1. 1 plus 5 does equal 6. Check. All right. Keep that in mind for something beyond the main test, if you know what I mean, Jelly Bean. Okay. Otherwise, I mean, there's, like I said, everything on the main test, you'd still, even the solving ones, you'd still use the idea of get the radical alone, square both sides, but at this point it will be like basic, easier solve for x, like solve to get x alone type of math or algebra. There won't be factor times factor stuff. Yes, there is a bonus. Oh, there's not a bonus on the final, Rhea, I don't believe, but I can tell you because I've got the final right here. That's the pre-algebra. Hold on. No bonuses on the finals, but the questions are only worth 2 points each. Because there are, as I think I told you before, but I shall remind you, 44 questions. So I will, as soon as we are off this class, you won't get above 100 for the one time. But as soon as we get off class, I will send you this test. You can get this test out of your way and start that practicing those problems. And like I said, if you don't think you need to go back and review chapters 1, 2, 3, because those are easy things like PEMDAS, combining like terms, how to multiply positives and negatives and stuff like that, you might want to do your study, study for your final exam stuff backwards, or go back, just start with chapter 4, 4, 5, 6, 7, 8, 9, 10. We will start with those early chapters on Wednesday. Okay? Yes, you will get points for writing your name on it. That's true. Okay. Oh, does anyone want to see the x-ray?